config or configuration management, if we go by the definition, then we can say that config management is the systematic approach to organize or store or access or basically maintaining all the settings. This is the keyword here. All the settings of our backend app. So you can think of this as a DNA of your application. It decides how your code runs in different environments. When you say configuration management to most people, then the first impression that we get, the first idea that hits our mind is storing some kind of database passwords, the secure connection URL of our database, or things like secure authentication keys, secret keys for your JWT secrets, etc., or any API keys of external services, like say your email delivery service, storing API keys for external services like that. So those are the things that comes to our mind whenever we talk about config management. But thinking like that misses a lot of scope in configuration management, because that's like saying a car is just about the engine. Engine is definitely the most important part of a car, but you're still missing out the 90% of the other features of a car. So similarly, configuration management, it has a lot of other things, starting from how your application starts up, how it connects to external services, how it behaves depending on different environments, what does it log, whether it logs or not, and where it logs, and where does it send all the details about your metrics, the performance metrics, your business metrics, and things like which features are we enabling for this version of the deployment, and which features are going to be disabled, and for which users we are enabling which features, etc. There is a lot of scope for config management. And in this video, I want to touch upon what are the different things we care about, what are the different things we think about whenever we talk about config management. It's not just limited to your database URL or your secret keys. It affects a lot of behaviors, important behaviors of your backend application. So definitely an important topic to discuss here. So let's say you are building an e-commerce platform. You're building an e-commerce platform. And if you are working on the backend of an e-commerce platform, then your configuration might include some of the things like what are the timeout details, what is the host, what is the port, what is the username, what is the password, etc., etc. All the connection details of our database. It might also have your payment processor API keys. Let's say you are using Stripe, then you might have your Stripe API keys there. Also your feature flags. What are the feature flags that we are enabling for this deployment, and what are the features that we are keeping disabled for this deployment? And these feature flags, let's say they control, we built a new checkout flow in our e-commerce platform, and using a particular feature flag, we can control that, whether we are still using the old checkout flow or we are using the new checkout flow. And we can also conditionally enable the new checkout flow for some users and the old checkout flow for some other users. So we use feature flags for these kinds of instances. You might also have performance tuning parameters, like what are we keeping our connection pool size, connection pool that we use for our database connections. Also security settings, like what is session timeouts, whether it is 30 seconds, 60 seconds. And we can also store things like business rules. Business rules for an e-commerce, it might contain things like what is the maximum amount of order for a user. And each of these different configuration that we talked about, starting from database connection details to payment processor API keys to feature flags to performance tuning parameters and security settings like session timeout settings, and also business rules. All these different configurations have different characteristics. Some of them are sensitive, some of them are supposed to be kept in secret. We are not supposed to leak them, and they might cause a lot of damage, they might cause a lot of loss. And some of them are not secretive, but they impact, they control how our application behaves while it is running. Also, some of them might change frequently, and some of them, let's say, they change once a month or once a quarter, etc. And some of the configurations may stay the same for all our environments, in our development environment, in our staging environment, and in our production environment. And some of the configs, they'll be different depending on which environment that we are running our application on. In all of this, there is one challenge, which is distributed systems. Most of our modern applications, all our modern backends, they don't run in isolation anymore. Most of them are now part of a complex distributed system, a system consisting of multiple services, databases, caches like Redis, etc., or message queues, or third-party integrations, or authentication, or emails, and a lot of things. And all these different integration points where we are connecting a separate service to our main backend, they all require configuration. Your backend, obviously, it needs to know how to connect to these services, but on top of that, it also needs to know how to handle failures, how to optimize performance, and how to maintain security, depending on different environment, depending on different settings, and depending on different configs that we can control from different sources that we will soon talk about. And this is the reason that most of our modern backends, they run on distributed systems. This is why configuration management becomes an important part of your application. And if you don't have a systematic approach, if you don't have a dedicated pipeline, if you don't have a dedicated strategy to manage your config, you will end up with what we call as configuration chaos. Configuration chaos basically means that instead of controlling some configs from a centralized point, you have hard-coded values scattered throughout your code base. And you also have inconsistent behavior across different environments. You also have security vulnerabilities from exposed secrets, and debugging your application becomes a nightmare because you cannot really reproduce these issues because you don't have a centralized way of managing your config. So you don't really know what exactly happened and what particular config caused a particular issue, what particular config caused a particular break in production. The stakes are pretty high for backend engineers these days since they handle the core business logic, and data is pretty much the most important part of any platform, any enterprise. So if you think about it, a misconfigured front end, it might show, let's say, a wrong feature, a wrong dialogue, which it's not supposed to show, or it might redirect to a wrong route. But a misconfigured backend, it can cause a lot of damage. It can expose customer data, it can process payments incorrectly, or it can bring down your entire platform if some important part of it is affected by it. Since backend systems run in diverse environments, different cloud providers, different on-premises servers, and containers, and serverless functions, and edge functions, and all have their own requirement of different configurations. Since we are talking about cloud providers, let me tell you a little bit about the sponsor of this video, which is Sevala, a platform as a service provider, and you can deploy your applications, your databases, and your object storage, your deployment pipelines, and you name it. If your team is paying per seat pricing in other platform as a service providers for your hosting needs, you are literally throwing your money away. I'll show you how you can save $300 per month while actually getting a better infrastructure and support. So this is the math. If we take a look at this, platforms like Render, they charge around $29 per month. And if, let's say, we talk about Railway, they charge around $20 per month. And platforms like Netlify, they want $19 per team member. So if you are a 5% dev team, that's around $145 to $290 monthly, just for the privilege of collaboration. And let's say your team is doubled. You have now 10 developers. Now you're looking at monthly $290 to $580 monthly just for the seat fees. You have other cloud hosting fees, Just for the seed fees, you are paying almost $500 per month before you even deploy a single app. If you can feel the frustration, then you can definitely check out Sevala. They don't have any seat based pricing. Sevala is basically a Kinsta product. Kinsta, these guys have been around for a long time. They are one of the most famous hosting platforms when we are talking about WordPress. And Sevala is their latest offering. Since they already had the infrastructure for all their hosting needs, they have created this product called Sevala. And the interesting thing about this platform is they don't have any seat-based pricing. Absolutely zero. Your entire team gets full access whether you have 2 developers or 200. But just because your costs have come down, do not assume that you are going to get lesser quality. Sevala uses GCP behind the scenes and the premier tier networking of GCP, and it runs Kubernetes behind the scenes with 25 data centers around the world with 99% SLA. They also have an integrated Cloudflare offering which has around 260 plus points of presence around the world, offering you things like Edge CDN, DDoS protection, and Edge caching, global load balancing, and a lot of things that Cloudflare natively brings. You get enterprise reliability without paying for the enterprise grade pricing. Sevala supports more than 20 programming languages through Nix packs, which is more resource efficient than traditional build packs. You get automatic deployments using GitHub, GitLab, Bitbucket, whatever version control system that you are using in your team. And also zero downtime Kubernetes health checks throughout your applications. You get features like hibernation pause for your development environments and horizontal scaling for all your production traffic spikes. But unlike most platforms, Sevala has a human monitoring system. Their support team actually monitors your deployments. If you are facing a lot of errors and facing a lot of challenges in your deployments, they reach out to you to help you out and help your team out. That's not something you'll see in a lot of platforms. They also have a lot of compliance checks. You have SOC 2, you have ISO, GDPR, CCP. It does not matter what your compliance needs are. They're already there. So if that sounds interesting to you, check out Sevala and you'll get $50 credits to try out different applications, database hosting, object storage, whatever your needs are. You can calculate your team's current seat-based costs and see how much you will save as compared to other platforms. Your CFO will definitely love the budget relief, and your developers will love the simplicity of the platform. So what are the different types of configuration that we are talking about here? Because not all configurations are created equal, and understanding the different types of configuration data is very important for choosing the storage mechanism, the security measures, and the access patterns, who can access and what environments a particular config should be accessible. So let's talk about what are the different types of configuration, what do they look like, where do they actually get used. The first one is our most common kind of config, which is the application settings. The application settings is the most common kind of config that you will see in most backend apps. And this basically includes our log level and things like our port, which port the backend application is going to run on, our connection pool size, our timeout values like if you have an HTTP request, then how long the server should wait for the request to get completed. So if you set a timeout value for 60 seconds and let's say you initiate a request which generates an AI image, your backend generates an AI image and sends it back to your frontend in base64 format. And the AI image generation takes, let's say, around on average 80 seconds. So if your server timeout is 60 seconds, then your request is going to get dropped. You will get a status code of 504 timeout status. Similarly, log level, in usually when we are developing our application on development environment, we set the log level to debug so that we can actually see and we can actually differentiate between different logs when we are creating the application, when the application is running on our local environment. And when we go to production, then we change the log level to info so that we don't clutter a lot of logs in our valuable production logs. Same way port, usually we run our backend app in local 8080, and depending on your production setup, whether you are using VPS or Kubernetes, you might have different ports. Same way, connection pool size for our database connections, all our database operations. Most backend apps use this technique called connection pooling. Connection pooling helps us optimize database connections. So we can also configure what is the maximum connection pool size that we want to have. So these are some of the common application level settings that you will see in pretty much all the different kinds of backends. Next up, what do we have? Second, we have database config. Now, database config basically includes all the details your application needs to connect to your database. This will include the host where your database is running on, the port of your database, the username of your database, the password, and the name of your database. All these different parameters combined, you can create a connection URL, and that URL can be used when your application is running to connect to your database. It might also have other parameters, things like timeouts, how long your database query should run for before it times out. Moving on, the third type of config that we can have is external services. Now, external services can be a lot of different types. If you are using emails, then you might have an email provider like MailChimp or something modern like Resend. Does not matter what provider that you use. You'll most probably have some kind of API key in your config that you will need to send the emails to initiate the client. Similarly, if you are using any kind of payment processor, let's say Stripe, then you might also have a Stripe API key. Or if you are using for authentication, if you are using something like Clerk, then you'll also have a Clerk API key. So all these different services that we call as external services, they also have their own configuration needs, and you'll also need to cater to that. Then the next type we have is feature flags. Feature flags exist so that we can dynamically enable or disable particular features of our application. So as earlier I gave an example, you are building an e-commerce platform and you have an checkout flow. You have a checkout flow where we have all the order details here, and here there is the payment details and proceed to payment, something like this. And now you're building a new checkout flow, and for that you are using a different API. And you don't want to roll out this new checkout flow for all your users. You want to do some kind of A/B testing with it. You want to only enable this feature for a particular segment of your user, depending on the location of the users. Let's say you only want to enable this feature for people who are from US, and you want to keep it disabled for people who are from India. If you have requirements like that, we use feature flags for dynamically enabling or disabling features in our application. So feature flags also need some kind of config management. So that's the fourth category. Apart from that, we also have other types, things like, let's say, infra config, all your DevOps related configs, and let's say your security config, your JWT secret, your session secret, anything related to security that your application is impacted from. Then we also have performance tuning parameters. So if your backend is built with something like Go or Golang, then you can set different environment variables like the maximum number of CPUs, etc. Then also we have business rules, different logic related rules that you want to enforce on application level, but you want to centralize that config. So that's when we use business rule related config management. So that's pretty much all about different types of config that you will face on your day-to-day life as a backend engineer. The second important thing is different sources of config, basically the storage of configs. If we have all these diverse needs of config management, then definitely we'll also need to think about the storing of the configs, and where you store your configurations. It depends on a lot of parameters. depending on security, depending on speed, and your environment. When we're talking about storage of configurations, then the most common kind that I have seen and most people have seen is the environment variables. And if you have worked with backends before, then .env. This particular pattern is very common among different backend apps. This is mostly common among Node.js apps, but we also have support for them in Python, Golang, does not matter what programming language that you're creating your backends in. This is the most common place where we store our configurations. If we are running in our local environments, then we have a file called .env. We use any library. A library called .env is very famous, which basically takes all your environment variables from .env and it loads it in your operating system's environment. So this is basically a feature provided by your operating systems. This is not something you built, but we have libraries which take these values from files and load it in our environment instead of us doing it manually with export. Similarly, if you're not in a local environment, let's say you are deploying in some kind of containerized environment using Kubernetes, etc., etc. So those technologies also have support for loading your environment variables while they are deploying your application. So this is the workflow that happens when you deploy it in a cloud provider using environment variables. The deployment triggers at a particular stage, it fetches all your environment variables from any kind of service, let's say from Vault, which is from HashiCorp, or something like this parameter store, or Azure, or Google Secret Manager, any cloud provider which gives this feature of secrets management. It fetches from all these cloud providers and it loads that in your environment. And then when your application starts, it takes those environment variables and it functions whatever way it is supposed to function. That is the most common storage we have for our configurations. The second kind is files. In files, we have different formats. We store configurations either in JSON, but these days YAML is more famous for storing configurations. One of the major disadvantages of using JSON is you cannot add comments. JSON does not have support for comments. That's why most people use YAML. There you can add your configuration and you can also add different comments so that it's easier for your team to share knowledge. We also have a newer standard, which is TOML file. This is also pretty heavily used for managing configurations. So if we were to take a look at a real world code base. So this is this is an example of Authelia. This is a authentication provider technology. This is a Golang application. As you can see, this have all these Go files. So here you can see we have a configuration.yaml file and there are different values. We have server, we have log level, this is debug, storage, our notification related details, identity related details, our regulations, session related details, and all these things. All of them are stored in a single YAML file. And if you were to search for config, then in the results you can see we have config.yaml in a lot of different places. This is from Incubator Answer. This is also another famous open source repository from Apache. And you can see they also have some fixed configurations for app settings that we just talked about. Application related settings like which port your server should run on. The databases for local environments, they are using SQLite and the Swagger UI config. So storing your configurations in a YAML file is pretty common in most of the open source repositories. Moving on, we also have key value stores or in-memory stores. For this, we might use something like Redis. This is most common, but we also have dedicated tools like Console or etcd. These cloud native tools, we also have access to them. Depending on your use case, you can use any of them. Key value stores are pretty lightweight and pretty simple to make use of. as compared to other complicated and hierarchical data structures for config management. This acts mostly like your environment variables. Then we also have dedicated cloud providers. Cloud. Here, majorly we have HashiCorp or Vault. Then we have AWS Parameter Store, also Azure Key Vault. All these different providers. If let's say we take a look at HashiCorp or Vault, you can explore all these different services which are dedicated for config management, your secrets management, that most companies use because we have deployment set up in a distributed manner. We have Kubernetes, we have auto scaling, and we also sometimes make use of different cloud providers at the same time for our scaling needs. So having all our configurations in a centralized manner in a tool, something like HashiCorp's Vault, which already is ready for all these different environments. They already have dedicated support. They already have dedicated docs and everything to make the integration as easy as possible. So using an external provider makes a lot of sense if you are running a big user traffic in production. But most of the time, we also make use of hybrid strategies. Let's say we have a file where we load all our configs and construct a runtime application settings. And when we are in this loading phase, we might fetch our configs from different places. In the first priority, we might fetch from AWS Parameter Store. Then we might also have a config.yaml. Then we might also have some environment variables. So we can pre-decide that which of these should have the higher priority, and depending on the environment, we can load those configs conditionally, depending on the priority and the environment. So that's all about different storages for storing our configs. Now, one question we have is, why do we have different configs depending on the environment that we are running on? And the answer to that is pretty simple, because each environment has a set of priorities that the other environment does not need or it should not have. For example, if we are running in a dev environment, whether it is your local in a dev environment, let's say in your local environment, you are running on localhost, then our number one priority is developer productivity and our debugging capabilities, so that we can work faster and we can catch issues faster. Similarly, if we are running in a test environment, we trigger a GitHub action and it prepares some kind of testing environment where we can run different integration testings or unit testing or whatever testing setup that you have. Then in that kind of environment, our number one priority is automated validation and quality assurance. Similarly, staging environment. Staging environment is basically a hosted version of our application that works and functions as similar to our production environment as possible, so that we have a clear idea what our production environment is going to work like, and we can make changes, fix issues, and debug issues accordingly. So that is the priority of the staging environment. Similarly, the last one, in our production environment, the number one priority is reliability and security and performance. So we create our configs keeping these priorities in mind. And that is the reason our configs are loaded in different ways, they are stored in different ways, and they are different in their values depending on which environment that we are running in. The application code, of course, it remains the same, but depending on the config, the behavior of our application changes, and that is exactly what we want. Without changing the code of our application, which we might have to do if we are hard coding things, but since we are centralizing our config management, we will never have to touch our application code. We can make changes in our config and that will reflect in the behavior of our application. So if we take an example of our database pool size in your development environment, when you are running in your local host, you can set your pool size, max pool size, for 10. And it mostly works fine while you are testing your application, while you are developing your application. You don't really face any issues because localhost these days, most people have high-end devices and it has a lot of capacity for these kinds of things. But on production, you have set the connection pool size to 50 because you have to cater to a large user base and you might get traffic spikes in different times. So you have to be prepared for that. So you have set a higher database pool size in your production environment. Similarly, in your staging environment, you have set the pool size to 2 because even though in staging environment, our number one priority is to mirror the functionality and the capabilities of our production environment as much as possible so that we can catch issues earlier. We can understand our production system better, but running a similar system which functions exactly like our production systems will cost the same amount when it comes to our cloud costs. And that's not something a lot of teams want. We want to save as much money as possible when we are talking about cloud costs. So in our development environment, our another set of priority is minimizing our cloud costs. So database pool size, since we already know that a staging environment is usually used by our developers or our testers. So we can take some decisions like keeping our database pool size to minimum, and we can accommodate some kind of delay there, but we'll save a lot of money in our cloud costs. And the last thing that we have to talk about when we are talking about config management is security. These are pretty obvious points, but just for the sake of covering all the scope, I'll mention these. Never hard code your secrets. If you have secrets like your production database URL, the API key of your clerk service or your email delivery service or your payment processing service, you should never hard code those secrets in your code base. Right? It's pretty obvious. I don't even have to explain why you should not. Second thing is, if it's possible, always try to go for a cloud secrets management service, something like, as I showed earlier, HashiCorp Vault or AWS Parameter Store or Azure Key Vault or Google Secret Manager. It's always a good idea to over-engineer when it comes to security of your backend application. These services, they already handle things like encrypting all your configs when they are stored in the storage. It does not matter where they store your config, but whenever they store it, they encrypt it and then they store it somewhere in any kind of database or any kind of storage. Similarly, when they are in transition, when you make an API call and you fetch all the configs, they send you the encrypted one, and with your private key, which is stored in your infra or your GitHub action or your repository secret or your Kubernetes environment, there they are decoded and then you use them. So they are encrypted when they are stored, and they are also encrypted when they are transferred from one point to another when you are fetching them. So these are essential security features, and when you use a cloud provider like Vault or AWS Parameter Store, all these things are already taken care of and you don't have to think about these. Third thing is access control. If you have a fairly large developers team, you should take some time to strategize who should have access to all your configs, following the rule of least privilege. Developers who are working on front end, they should only have access to all the configs that they need for functioning. Things like the API URL of the backend and different API keys for front end integrations, etc. And if you have backend engineer, they should only have access to your databases, your Redis instance, your Elasticsearch, etc. But something like configs for accessing your cloud instances, your EC2 instances, only your DevOps team should have access to those. So following the least privilege principle, you should strategize your access control, and you should also have things like rotation. Periodically, you should rotate all your configs, all your API key secrets, all your JWT secrets and things like these, so that they are not very prone to leakage. And the last thing that I want to mention here is validation. Most of the times that I have personally seen, we don't always validate our environment variables or whatever source our configs are coming from. Let's say if we are using .env, then we just use some library called .env. We load all the variables in our environment and we just access it using process.env whatever the name of the variable is. But one of the key strategies that can help decrease a lot of headache is when you are loading your config, which is usually the start before your application starts, after it is deployed, you should validate all the configs. Does not matter whatever source they are coming from, if they are coming from .env, if they are coming from AWS parameter store, if they are coming from a file, let's say config.yaml file. Always validate them using a proper validation library. If you have a TypeScript backend, then you can use Zod. If you have Go, you can use Go Validator Playground library, any kind of validation library that your programming language, your framework offers, and properly validate all the variables depending on which ones are mandatory to provide, which ones are optional, and you're setting the default in your application code. And thinking about all these different scenarios, always validate your configurations. I have learned this the hard way. It can cause a lot of damage. It can cause a lot of confusion in your production environment because it's not very easy to spot that you have a mandatory environment variable requirement, but you were not able to provide it, and now your production system is either breaking or behaving in a strange way because it does not have access to a particular environment variable. If you were to take one thing from this video, this is the most important part. Always validate your configs. Does not matter where they are coming from, always validate them.